There are mainly three laws of vector addition, one being triangle law of vector addition, another being parallelogram law of vector addition, and third being polygon law of vector addition. So one by one, we'll go in detail and find out what these laws are. In a statement, we can find three important things here. One being that the vectors has to be like vectors. What do you mean by like vectors? Like vectors means they are of same nature. Like vectors v f1, f2 are two vectors which represent force, whereas v1 and v2 are two vectors which represent velocities. So the vectors, two vectors acting simultaneously at the same time on the same body has to be in the same order represented by two sides of a triangle. So if we have f1 as one vector and v1 as another vector, these two vectors cannot be taken into consideration for a triangle law because they are of unlike vectors. For triangle law, two vectors has to be of same nature. Let us consider two vectors, vector p and vector q, acting on a body simultaneously. Let theta be the angle between them. If we take vectors p and q in same order, so this vector can be represented as this vector starting at the end of vector p. Now this is taken in the same order, that is anti-clockwise. So by triangle law, the closing end is the resultant of vector p and q. Now this resultant is in opposite order, which is clockwise. Now if we extend this line, if we draw perpendicular, so this has to be 90° and this has to be theta, which is the angle between p and q vectors. Most of the students do mistake while taking this angle between the two vectors. Here theta, this is the angle which should be taken, whereas most of the students I have seen take this angle, which is the supplementary of theta. When we take angle between two vectors, it is very important to notice they have a same common point. As we see, this is a common starting point. We have common starting point here. If we take a common starting point, we can represent this as p vector again. We don't need to write it again. We can represent by phi vector concept. So it becomes the common starting point. So theta is the angle between p and q. Let phi be the angle made by resultant with p vector. Let it be a, b, c and d. So if we take triangle b, c and d, in triangle b, c, d, we have to find bc and cd. So if we take sine theta, which is always p by h, p being cd and h being q vector itself, we take the magnitude only. So cd is equal to q sine theta. So this is q sine theta. Again, if we take the same triangle BCD, this time we take cos theta, which is always b by h, b being BC the base and h being the q itself, BC is equal to q cos theta. So this becomes q cos theta. Now if we take this triangle A, C and D, we can use Pythagoras theorem. So AD square is equal to AC square plus CD square. AD is a resultant, that is R, so we can take magnitude square is equal to AC, which is AB plus BC, that is P plus Q cos theta whole square plus CD, that is Q sin theta square, where resultant R magnitude is represented by R, P magnitude is represented by P, and Q magnitude represented by Q itself. So if we find R square is equal to P square plus Q square cos square theta plus 2PQ cos theta plus Q square sin square theta, R square is equal to P square plus we can put these terms together. So Q square cos square theta plus sin square theta plus 2PQ cos theta, R square is equal to P square plus Q square, whereas cos square plus sin square theta is equal to 1. So plus 2PQ cos theta. We can write resultant is equal to P square plus Q square plus 2PQ cos theta. So this is the magnitude of the resultant. So we now know what is the magnitude of this resultant, which is equal to P square plus Q square plus 2PQ cos theta. Now we have to find this phi. This phi is the angle made by resultant with the P vector. So if we take triangle A, C and D, again we can use trigonometric function. Phi is P by B. We know P is Q sin theta. We have taken this vector, we have taken this triangle ACD, so this is the perpendicular, and we have base, that is P, this plus Q cos theta. So phi is equal to tan inverse Q sin theta plus P plus Q cos theta. Now we know this is the magnitude of the resultant and this is the direction made by resultant with vector P. So in this way, using triangle law of addition of two vector addition, we can find the resultant and the resultant magnitude and direction.